Hello and welcome to this topic on forecasting. And more specifically, we will talk about the Holt-Winters multiplicative forecasting method where seasonality is present, we have trend, and the amplitude is increasing. So there's another Holt-Winters multiplicative with seasonality, no trend, and increasing amplitude. Here, though, to reiterate, we will cover the Holt-Winters multiplicative with seasonality and trend and an increasing amplitude. All those concepts were described in a previous forecasting recording. There are plenty of formulas. There are a lot of formulas. It seems, as you see here to the left, as we see here, but I have broken it down into steps, small steps, so that the whole process will be explained with numbers, and I hope that it will be very, very clear as to what is going on. So here is the model. And once again, the multiplicative model applies to time series whose amplitude increases or decreases over time along with a trend. As with a no trend case, a chart of the time series should be viewed first to identify the appropriate type of model to use. Three parameters, alpha, beta, and gamma, are used to smooth the level. Alpha is the level, beta is the trend, and gamma is the seasonal factor for the time series. So let's do exactly what they said. I'm going to go to the data, the initial, the data, and the data is made up of the month column, it's in gray. These are the tractor unit sales of the PLE, Performance Loan Equipment Company. So the three columns that we will consider to do this graph here are the month, the period, and NA. We will actually use the month and NA. Period 1 is January 10, period 2 is February 10, period 3 is March 10. So I can either use the month or the period together with NA, which stands for North America. The numbers underneath NA represent the tractor unit sales for PLE in the month of January. So for example, in the month of January, there were 570 tractor units that were sold. In February of 2010, there were 611. If I take these three columns and select them, and then go to insert recommended charts, you will see that we get we get this chart, or this one here, and basically, so actually I should have selected the month column and the NA column, those two. If I select those two and then click insert recommended charts, I see that this is the graph. I stretched it out and I've added, you see these horizontal and vertical lines. I've added those because I actually want to add another vertical line here. So the data starts in January of 2010. So that should be, that's here. Okay. Let's color that black. And if we go from January to January, we see, I'm approximating here, it doesn't show this on the x-axis by months, but I mean, it shows by month, but it shows every 8 months. So I'm approximating. Basically, what I want to tell you is that I'm drawing these vertical lines to show that we have seasonality. You see this graph goes up and down, up and down, up and down. So here you have one season, basically. Okay. And the graph repeats itself. The graph repeats itself every every year. It kind of repeats itself. I think the year is about there. So so I'm showing you. So here you have season 1, season 2. A season is 12 months. And this sort of goes upwards, slightly upwards in the beginning, and then it takes off. So you see that you have a trend. So we have seasonality, okay? We also have a trend because this graph goes at an angle, okay? And then we have the amplitude is increasing. So if I go over here, amplitude is the height from the lowest to the highest, okay, in subsequent seasons. So here is the amplitude. So this is amplitude 1. Here is the other amplitude, amplitude 2. Here is another amplitude, amplitude 3, and so forth. And you see that the amplitudes are increasing. So we have seasonality, we have trend, and the amplitude is increasing. This means that we can use whole winters multiplicative with seasonality, with trend, and increasing amplitude. Okay. So we need to do the graph, and we did the graph with these two columns. Again, this column and that column, all right? These two columns are basically the same thing. Instead of using a month, we use a period number. So that's the period, okay? T equals to 6 in this case. Okay, so we will need 3 parameters, 3 smoothing constants, and those are shown right here, alpha, beta, and gamma. Alpha is called the level component. Beta is called the trend. Gamma is called the seasonal. So you see, when we have basically, we have these 3 smoothing constants, I will generate the average of the actuals of the first year, the first season, and then I'm going to generate a special average, but I will talk about that shortly. This is the actual, this is the answer to this is how I do the multiplicative, okay, with the actual tractor data. And okay, but what I want to do here to the right, I want to go and explain the algorithm, which is basically which is basically how it's done with the software. Okay. Okay, so once again, here is where we have S, small s, is the number of periods in each season. So S is 12 because we have 12 months in a year. I am initializing alpha to 0.4. I'm initializing alpha to 0.4, beta to 0.7, gamma to 0.9. Alpha, beta, and gamma do not have to add to a specific. So alpha plus beta plus gamma doesn't make sense, right? So I read this part. This is the, here we have the model. This is the model. This tells you how the T will represent the current period, and T plus 1 represents the next period. So this is the forecast value of the next period, which I can also write as F of T plus 1. The forecast value for the next period equals A is one of the it's the level component. Okay, so A of T, the formula is right here, plus B of T, the trend component. I add those two up, and I multiply this times the seasonal component, and this is T minus S plus 1. So I can write it either this way, okay, or this way. They're exactly the same thing. Alpha, beta, and gamma are the smoothing levels for level, trend, and seasonal factors. And the smoothing, those factors are the level component factor, A of T, the trend component factor, or B of T, and the seasonal component factor, S of T. Okay, so you see we use alpha for A of T. This is alpha. To smooth things over, we use beta for B of T. And we use gamma for S of T, okay? So, all right. This ratio here, this is uppercase A of T. Uppercase A of T, which we can write this way, this is the actuals. These are the given numbers, the given data, the actual data, the actual tractor unit sales. This ratio right here of uppercase of the actuals divided by seasonal is called the deseasonalized estimate for period T. Deseasonalized estimate for period T. Okay. So when we calculate the level component, you see that for the level component, A of t, this is equal to alpha times something plus 1 minus alpha times something else. Okay? This alpha is a scaling factor or a weight. Alpha is between 0 and 1. So if alpha is 0.8, right, right here, if this is 0.8, then 1 minus alpha would be 0.2. So 0.8 of this guy here, okay, of the deseasonalized factor, A of t over this S of t minus S. So we will count this more than whatever is here. And here you have the A of t minus 1 plus B of t minus 1. And this, of course, can be written as this way. Please do not confuse the A, which is the seasonal factor, and the alpha, which is the scale for the seasonal factor. Okay, so do not get carried away with the symbols, okay? I want you to get the idea. Okay, then we do a similar analysis with the trend component. And the trend component, B of t, equals beta times something plus 1 minus beta times something else, right? And beta, again, has to be equal between, it has to be between 0 and 1. So if beta is I use 0.7 here. If beta is 0.7, 1 minus beta will be 0.3. So again, whatever this thing here is, we count that more than we count whatever is inside the second brackets. All right. All right. We then have the seasonal component, S of t, which is gamma times something plus 1 minus gamma times something else. Okay. This here is a ratio of the actuals over the level component. Okay. And this is the seasonal component and t minus s, which I'm going to illustrate that. So gamma is also between 0 and 1. So if gamma is, let's say this is 0.2, then 1 minus gamma would be 0.8, which means this guy here, all right, counts more towards calculating the seasonal component than this guy right here. Because 0.8 times something, right, is a lot more than 0.2 times something else. Okay, so the term, this term of actuals over the seasonal component is an estimate of the seasonal factor for period t. Okay, so so let me let's go over here. All right, and here, as you see, I am saying that this is season 1. This is here we have season 1, the first 12 months. Period 1, this is January of 2010, February of 2010, March of 2010, and so forth. Okay. If I name T, if T is month number 7, then T minus 1 is month number 6, and T plus 1 is month number 8. Okay. We will do a lot of initializing in the first season. So, and I say we know the period, we know it, all right? T minus S. S, anyway you see lowercase s, is equal to 12. So this T minus S, so here is T. This is T. So T is 1. T minus S would be 1 minus 12, negative 11. This is 2 minus 12, negative 10. 3 minus 12, negative 9. So we know this column also, okay? We want to start using data with, we will be using this T minus S when we go to season number 2. Here we have the actual unit sales, so we know that too. Okay. The T minus S plus 1, which is a subscript used somewhere, you see this is, so T minus S. So this number is, T is 1, so I'm explaining this, right? So T is 1, so this is 1 minus 12 plus 1. So this is negative 10. This one right here, okay, this one, T is 3, right? So T minus S plus 1 is 3 minus 12 plus 1, and so this is negative 8. So we know this, we just, okay, and the reason that I'm calculating these columns is so you can see where things come from as we are moving along. Okay, the columns that I want to calculate are the level component, the trend component, the seasonal component, and the forecast, okay? The forecast is not a component, it's just forecast. But in the orange region, we will do a lot of initializing. So for the first season, again, this is all done for the first season, all right? This says that A1 will be equal to A2 will be equal to ... will be equal to A12. And you find this by finding the average of the 12 actuals for the first season. Okay, and so S is 12. So you see 1 over 12. So all of these A's, all of these level components, A1, A2, ... equals to A of 12. This is, okay, each one, they will all be the same. And so you add the 12 actuals. Okay, whatever this this gives us, and I actually have done this when I calculated, when I did the real problem, and that was 538. Okay, that was 538. Okay. Oops. Right here. So we put 538. We put 538 everywhere. 538, 538. So we initialize the level component with 538. Okay. Okay. The next item that we calculate is we can we can find, let me find S of t, okay? In the formula for S of t, so basically you have S of 1, let's do it over here. S of 1 equals to S of 2 equals dot, 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 equals S of 12. Oh no, I'm sorry. S of 1 equals actual 1 over the level component. S of 2 equals actual 2 over A of 2, right? And, and we have them. So for S1, A1 is 570, okay? Actual one is 570, and lowercase a1 equals to 538. So whatever this gives us, this would be S of 1 right here, right? So this is 570 over 538. S of 2 is 611 over 538. S of 3, uppercase S of 3, is 630 divided by 538. So far we found, and we found the level component for the first, which is the same for the first 12 periods, and then the seasonal component, right? Okay, the trend component is found kind of differently. And let's make some space. So this is the formula to find the trend component. Okay, so B1, okay, so T, when T is 1, B1 equals 1 over 12, okay? And this is the summation sign. The uppercase Greek letter sigma is summation. And this is I equals 1 all the way to 12. So when I is 1, then you have A, okay, S is 12. I is 1, so this is actual of 12 plus 1 minus A of 1 divided by 12. Then I, it becomes 2. So now I becomes 2. So you have A actual of 12 plus 2 minus actual of 2 divided by 12. And you keep going until I becomes 12. So this would be, the last fraction would be actual of 12 plus 12 minus actual of 12 over 12. So that's B1. Now you see that the t does not come into play in this part, in this formula, right? So when I calculate B2, it will be the same as B1. When I calculate B3, it will be the same as B2 as B1. So actually B1 equals B2 equals dot, 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 dot equals B of 12. So now this A of 12 plus 1 is A of 13. Okay. So so when I calculate B1, right, this would be 1 over 12. And then you have actual 13 minus actual 1 over 12 plus actual 14 minus actual 2. It's a good idea to use this parenthesis because otherwise you can get mixed up, okay? Plus dot, 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 okay? So if I move things down a little bit, okay? So I know I found the level component, the seasonal component, and here is B1, okay? So here is B of 1. But the way I stretched it out, B of 1 uses, here we have this right here is A13. This is A14. And I can write it like this, or I can write it like this. When I say A, it's uppercase A, right? So actual 14 or big A parenthesis 14. To write it like this, A with 14 as a subscript is the same as to write it uppercase A parenthesis 14, right? Subscript index, same thing. Okay, so when I find B1, when I found B1, and I want to go slow here, right? Remember, B1 was 1 over 12. And initially we had actual 13 minus actual 1 over 12. Well, here is actual 1. This is actual 1, all right, the actual in period 1. And here is actual 13. So you take, so this here would be 571 minus 570 over 12. Then you have plus, it was actual of 14 minus actual of 2 divided by 12. Okay, well, this is actual of 14 and this is actual of 2. So that would be plus 650 minus 611 over 12, right? And so forth. So with all of this, we know now that we have the level component, the trend component, and the season component. Okay, the the formula for the forecast, the formula for forecast is this guy right here. Is this guy right here? This formula right here. Okay, which says the formula, and here it will be a little bit tricky as to how this is going to be done, of period f plus 1 equals the sum of the level factor, okay, the level component, plus the the trend component multiplied times the seasonal component of t minus s plus 1. But we want this t minus s plus 1 to be a positive number. Okay, this needs to be greater than or equal to 0. Okay, so it needs to be greater than 0. Okay, now, so the first time that that this let's go up. This t minus s plus 1, if we go down here, the first non-zero number, the first positive number is this number right here. So the first let me grab this. Okay, I can move this down. Right there. So the first time that that I can find, the first time that I can find a forecast is actually when I'm right here. So if I try to find this value here, okay. Now let me actually try to do it. That's why I plotted this in green. So if I want to find this forecast value in this cell, okay, using this formula f of t of 1, f of t plus 1. So the period t here is t, the period here is 15. I want to find f of t plus 1. I want to find f of 15 or f of t plus 1. Okay, so t then is 14. Okay, so because of the notation that I'm using, this formula could be written in another way. Okay, so so I want to find f of t plus 1. So if I am in period 15 and I want to find f of 15, okay, using this formula f of t plus 1, in the formula, right, t is 14. So f of 15 would be equal to a of 14 plus B of 14 times the seasonal component of T minus S plus 1. And T is 14, minus S is minus 12, and plus 1. And what does that give us? This gives us 14 minus 12 is 2, plus 1 is 3. So this here is seasonal component 3. And where is S of 3? T is 3 right here. So S of 3 is right here. S of 3 is right here. Okay. So this is the trick right here. The if I wanted to find if I wanted to find f of 13, the forecast of f of 13, right? That is equal to the level component of yeah, let's be careful here. Now, we use this formula, right? Equals to f of, this is t plus 1. So this means that t equals to 12. So we have f of 13 is equal to f of 12 plus 1. This would be then the level at t, 12, plus the level component, plus the trend component, times the seasonal component of t minus s plus 1, and that would be 12 minus 12 plus 1, which is 1. So this is s of 1, right? And where is that s of 1? I keep missing something. Uy. Oh, well. So to find f of, to find the forecast here, to find this forecast, we borrow the seasonal component S1. You see, if we try to find this forecast right here, that would have been f of 12 equals to f of 11 plus 1, okay? And the seasonal component, t minus s plus 1, would be 11 minus 12 plus 1, which would be 0. So we would look for s of 0, and there is no, we don't have s of 0. And if we try to find this forecast value, we would try to find s of -1, and it doesn't exist. So now you see why we could not find the forecasts in the next in the first season. Okay, but we can definitely find the forecast for the second season and the subsequent second and subsequent seasons. So we are now in season 2. So we filled out, basically we filled out everything. We filled out this, that, this we cannot find. And now we are in season 2. Now we are in season 2. In whatever we do in season 2, we do in other seasons as well. So here is season 2. And these formulas apply to season 2. Right? And in fact, I showed you how we find the forecast value. This is okay. This column here, I'm going to put the labels. This is A of t. This is B of t. This is S of t. Okay. And so I can move it up a little bit. Right. Right here. All right. So how do I find A of 13? Here is the formula. A of 13 A of 13 equals alpha, which we know. I forgot what I put for alpha, right? Alpha, and then times A, the actual at 13, divided by the seasonal of t minus s, right? T is 13. So this is 13. S is always 12. So this is 1. So this is S of 1. Okay. Plus 1 minus alpha. Again, we know alpha, so we know 1 minus alpha. Times A of t minus 1 plus B of t minus 1. So t is 13. Therefore, t minus 1 equals to 12. So this here is A of 12 plus B of 12. Okay? So if I grab all of this, and move it out. Oh, what is this? What did I do? Let's move it out of the way. I have it right here. I want to find, remember, I wanted to find this, okay? So I have the formula here. I have everything that I need to find it. Right here. I'm missing some pieces here. So I want to find this. I have the actual on period 13. I have the seasonal component of period 1. I have alpha. I have 1 minus alpha. I have the level of period 12, which is right here. This is A of 12. This is B of 12. All right. Alpha I know. S of 1 is in period 1 right here. Okay. This is S of 1. So I can find A of 13. Okay. Then I can find B of 13. B of 13 using this formula right here. And B of 13 equals beta that we know times this part right here. And this would be A of 13, okay, minus A of 12. And we know both of them. A of 13 is right here, A of 12 is right here. And beta we know once again. And then plus 1 minus beta times B of 12. So we know everything. So we can find B of 13. Then I want to find S of 13, the seasonal component, and S of 13, equals to gamma times the actual at 13 divided by the level at 13 plus 1 minus gamma times the seasonal of T minus S. Well, T is 13. S is always 12, lowercase s. So T minus S, lowercase t minus lowercase s, is 13 minus 12, or 1. So this here is S of 1. So this is S of 1. So we now found all of these, all three of these. So we were able to find the level at 13, the trend component of in period 13, the seasonal component of period 13, and what has remained to be found is f of 13, okay, which we did, which is f of 12 plus 1, right? We're using f of t plus 1. and and here's the formula. As we did, so f of 13, so f of t plus 1 equals to f of 12 plus 1, right? And this would be equal to the level at 12, period 12, plus the trend component in period 12 times S, and then of this subscript, T minus S plus 1, this is 12, this S is 12, and then plus 1. So this here is 1. So this is S of 1. And we have all of them, this, and that. And from this point onward, we can find the we can find the rest until the end. We can find the A of t, B of t, S of t. So this is the A of t column, lowercase a of t. This is the level component. We can find B of t. We can find the seasonal component, and we can find the forecast. And we can go all the way to the end. All the way to period 60. So we are then, we filled out all of this, and we found the forecast column, the forecasted values. But up until now, okay, we have in periods 1 through 60, we have both actuals. We have actuals in periods 1 through 12. We have actuals in periods 12 through 60, and the actuals are the A of t, right? We have both actuals and forecasted, okay? We have both actuals and forecasted. We have both actuals and forecasted, okay? Why did we do all of that? We did all of what we did so that we can generate forecasted when we actually do not have actuals. And this is the next part. Okay, so these are, I repeat the headings at the bottom so that we know what the numbers above are. So the periods, this column is the periods, this is that t minus s, the actuals are these numbers, this is the t minus s plus 1, this is the level components, the trend components, the seasonal components, and the forecasted. And I put comments here, so when you move inside, when you click inside this cell, it gives you, or just move the cursor over the cell. Now, the formula that we will use is this formula right here to find forecasted, okay? So, and I will explain this for a couple of rows, and then you'll see what it is. Anyway, you see the uppercase letter T, that is 60. It is the last, the maximum value of lowercase t. So uppercase T is the max value of lowercase t, and that is 60, right? We know that T, the period, goes from 1 all the way to 60. So this right here, and I colored this in blue because this is my last record where we have actuals and forecasted values. So uppercase T is a constant. So anyway you see uppercase T, it's a 60. So this is the formula to find forecast values when there are no actuals. So you see, there are no actuals here, right? We are doing this, we are right here, time-wise, we are right here, we are right after month 60, okay? Or we are doing this, so now is at the point we have collected all these 60 rows, right? So right now we are at the point where we have all these 60 actuals, okay, and and we filled in the 60 rows above us, all these things here. And I want to be able to forecast month 60, I forgot where it was. Was it December of 2014? So month 60 is the December of 2014. Let us actually go there to see what month 60 is. So month 60, yeah, it is December of 2014. Okay. So when I have k equals to 1 right here, this corresponds to month 61, which is January of 2015. Let me clear the screen. Okay. So if this is T, that would have been 61. If this is the month, that would have been January of 2015. This would have been 62, 63. So the formula then for, this is the formula to find forecast for K periods beyond the last period of observed data, period T. So this formula right here so that's F of, anyway you see uppercase T, put 60 in it. And this is S of 60, lowercase s is 12. So we have F of 60 plus K equals to the level at 60, period 60, plus the trend component at period 60 times K, and this is uppercase S of 48 plus K, all right? So if we, let me grab these. And move it out of the way, move it, let's say, right there. My screen froze. So, oops. Okay. I see that my screen froze here, but you can basically see, oops, that this value right here would be A of t, or A of 60. And what is A of 60? This is lowercase a of 60. It's whatever I have here. The level of A of 60 is, okay. All right, it seems to be back. It froze there for a little bit, so I apologize for that. I don't know what happened. um, but basically, I was right here, and we have the the formulas for. Let me start this again because I'm not sure at which point it froze. Okay. So let me repeat this here. So this is the formula that will give us the forecast for k periods. K is 1, 2, 3, and so forth, after the last period of the observed data, period t. So uppercase T is the last period. It's 60. Okay. And I did say before, but I'm not sure if it was while we froze, lowercase t is between 0 and 60, periods, 1 and 60. Okay. And uppercase t is the maximum value of lowercase t, which is 60. So this is the formula that will give us the forecast for periods during which we do not have actuals. This is the actual column, so we do not have any actuals. So let's say k equals to 1. Okay, let's erase everything. So k equals to 1. This here is a of 60, which is this value right here, right? The next, when k is 2, this is the level component is a of 60 again. So all of these are a of 60. All of these are b of 60, which is right here. Okay. This is s of t. Okay. This is s of t, and and in the formula for s of t, okay, the formula for s of t, the formula for s of t equals actually, I don't know if we need that here. Let's see. Actually, we don't need that over here. We just need to find, so we do not need this, we need to find this. So, so we have, let me make some clean space to find, okay. So let me just clean this up a little bit. Okay, I'm right here. So I want to use this formula right here. So we know that t equals to 60. We know that k equals to 1. We know that lowercase s equals to 12. So I'm trying to find, so I know that this is a of uppercase t, which is, I want to do this nicely, okay, which is equal to whatever this is, right here. This is also that value that we have in blue. And t, lowercase t minus lowercase s plus 1, right here. Uppercase t, this is the formula that I'm using, okay? Uppercase t minus s, lowercase s plus k would be 60 minus 12 plus 1, which is 49. So f of uppercase t, which is 60, plus k equals to 1. This is that value right here, right? Equals to, I'm using this formula right here, equals to lowercase a of 60 that we know, plus lowercase of b at 60 that we know, times uppercase s of this subscript, which is 49. But we know that, okay? Of 49. But we know that this is the seasonal component in period 49, which is where it is right here. See, this is period 49. This right here, this is S of 49. Okay, this is 49. So we can find this guy right here. Similarly, we can find this here. This would be f of, remember this is the formula that I'm using, f of 60 plus 2. So the formula is uppercase f of uppercase t plus lowercase k equals to a of uppercase t plus b of uppercase t times s of uppercase t minus lowercase s plus lowercase k. This t, you can hard code 60, all right? So our next f value right here is f of 60 plus 2. This is a lowercase a of 60 that we know, plus lowercase b of 60 that we know, times s, and now this uppercase t minus lowercase s plus lowercase k is 60 minus 12 plus 2, which is 48 plus 2, or 50, right? And where is s of 50? Is right here. This is s of 50. How do I know that? Because this is t equal to 50. So, and then you do the same thing for the rest of the values. Okay, now what we can do, and in fact, I have done all of this. I have done all of this for you right here. Okay. Anytime you see HWM, that stands for whole winter multiplicative trend. Okay, so I've calculated these forecasts when we do not have actuals. All right. Above here, I calculated. Let me make this a little bit smaller. All right. So you see here, for the first 60 periods, I have this is the first season where I have actuals, but no forecasts. Just move it to the right. No forecasts. Then for periods 13, all the way to 60, period 60, here I have by the way, before I continue with that thought, for the first season, I calculated these guys to show you in detail, how I find B of t. I do not use this space for periods 13 through periods 13 through 60. So this area is unused. So you have some columns that you need here and some columns that you need over here. Okay, there you go. So the forecasts are right here. Okay, and to the right you have the theory. So basically you have the answer to the whole question of doing whole winters. This here stands for whole winters multiplicative. S is for seasonality, T is for trend, A is for amplitude. Okay, and what I do at the end, I take all of my data. I take all of my data from the first period all the way to 60, and you see that in these first 60 months, I do not have forecasts for the first 12, and then in months 61 through 72, I do not have actuals, but I have forecasts. So what I want to do, I want to plot the actuals and the forecasts. So I grab this column, the actuals, all the way to the end, plus I go all the way to the end. These are the actuals, even though I don't have some here. So let me go and grab this. Okay, all these actuals. Then I press the control button and I grab all the forecasted, including when I don't have forecasted. Right? And then I click insert recommended charts. And okay, I should actually have, no, I should have picked the period, the actual. I should pick these three actually. Sorry, the period, the actual, and the forecasted. Right here, insert recommended charts, and you see this right here. This has the actual and the forecasts. And let me erase it because I have the whole thing over here. And this graph shows us the tractor unit sales forecast for periods 1 through 72. And we see that for the first 12 months, we only have actuals. Then we have in blue the actuals and in orange the forecasts. And in the last 12 months, we have forecasts and no actuals. And this shows you how well we are doing for the when we have actuals and forecasts. And this is where we are, the whole idea behind doing what we did is to be able to forecast at the absence of actuals. So this was the multiplicative, whole winters multiplicative method. Let's go to the beginning. Here. So this was the whole winters multiplicative with seasonality and trend and increasing amplitude. There's another version of it, which is the whole winters multiplicative with seasonality, no trend, and increasing amplitude. Of course, the idea is extremely close. Thank you very much. This is recording number 6 for forecasting. Thank you very much. I will see you in the next recording.